Hello everyone and welcome to this my video on proving and applying similar figures. My name is Darren from Maths Guru. Really lovely to see you. Thanks very much for joining. Hopefully it's going to be a good video. It shouldn't be too long, to be perfectly honest with you. There's not too much in this and it builds on the videos before. You say, before? Where can I find these videos? Well, of course you can find them on mathsguru.com, my little corner of the interweb. Basically, everything I'm about to write on behind me is downloadable. The videos are all there, sequenced. What else is there? Exam questions, VCE stuff. I know it's a bit early for you, but it's there for you. And it's pretty good if I do say so myself. Maybe you can tell your friends and your teachers. And while you're at it, can you subscribe to my YouTube channel, please? Very few people watch my content, and when people do, it means the world to me. And the only way I can really know that is if you subscribe, all right? Turn off notifications if you need to. I don't spam people, trust me. But the work is there to try and help, and hopefully it will do. So, enough of the needy stuff. Let's get on. Now, recapping what we've done in previous lessons. Now, when we did congruence, which was really cool, we said that triangle ABC was congruent to triangle DEF. We meant that the angles inside were exactly the same size and the length of the lines were exactly the same size as well. So that's congruence, okay? It means they are exactly the same size. We can turn them, we can flip them, they're congruent. Last lesson we talked about similarity, and we said the similarity that the angles were the same inside, all right? So the angles would be the same size, but that the lengths would be the same ratio. So when we're doing similarity, when we're testing for similarity, we really do have to make sure that the sides are the same ratio. And we also have to make sure that the angles inside are the same as well. So in the same way as with congruence, we had 4 tests, there are also 4 tests here, which are SSS, SAS, AAA. Now that's very different from the last one because if you remember, and I can't help myself from giggling, AAS, yes, and RHS. So these are 4 rules that just go in your summary book. Now the problem with this particular section is you've got to prove they are similar, and you can't just turn around and go, oh yeah, they're similar, because you've got to show step by step your calculations. Right, now how are we going to be able to do this? So if we look at this one here, what do we notice? Well, we don't know the size of the angles, but I'm fairly sure they're going to be the same. I don't know the side lengths. I don't know this. I can't work out a ratio. So basically, I can't use anything with an S in it. So the chances are I can only use AAA. Because if you remember, we've got, what did we have? Let's go back to the rules. We had SSS, I can't use it. SAS, I can't use it. RHS, I can't use it. Because all of those there have side in it. And we don't have ratios. I can't work out ratios of sides. So the only one I can use is AAA. So now what I've got to do is got to show that the angles inside these 2 triangles are the same. Well, how do we do that? Well, we build on the knowledge we've got of parallel lines. Again, another video on mathsguru.com. Right, so what do we know? We've got 2 parallel lines here, and which means that I can draw a Z, which means that that angle there and that angle there are the same. So ABC and CDE are the same. So where is that? ABC and EDC are the same. Again, the letters and the order don't really matter. So what you've noticed here, I've written a qualifying statement to say that angle, notice it's not a triangle, it's an angle, ABC. Now again, whenever you write triangle, when you ever write that ABC, we're really talking about the angle in the middle of the 3 letters. So that's just a way of saying angle B, all right? But angle ABC is also fairly nice, is equal to A. Now again, what we've put is we're not just said that they are the same, we've said why they're the same, and they're the same because of alternate angles.